Hi everyone. Today I'll be going over how to make an exploded assembly and how to make a drawing for using that exploded assembly, as well as a few other things associated with that. So basically, we'll be going over what properties you could add that makes your BOM, which is your bill of materials, more descriptive. So you can add your properties actually to your bill of materials, which I will show you guys later. We'll also go over some mates as we do the assembly in the assembly view, in the assembly environment, and some tips for that as well. We'll then make the exploded view, which we'll then put onto a drawing. And then from that drawing, we can then add a bill of materials that list out all the parts, and as well as other properties of your parts. And then we'll end off by adding a few balloons, by adding balloons, by adding balloons, which essentially just labels our exploded view. So let's start by looking at our individual parts. So I've just quickly made up 3 parts, as you can see here. As you can see here, assembly demo 1, assembly demo 2, assembly demo 3. Essentially, I'll be using these 3 parts that I made as an example to demonstrate how to make an exploded assembly and its associated drawings and bill of material, etc. So a good rule of thumb is actually to, regardless of what material you actually choose, apply a certain like color or texture, basically appearance, right, to the part, so you can more easily differentiate your component, a specific component from the rest of the assembly. So you don't want an entire assembly full of like one color, then it gets very confusing, especially when you have many different components, many different parts in your assembly. So when you have a lot of parts in your assembly, you want to just diversify the colors a little bit, at least, so they can stand out to you more easily and make it easier for your audience to comprehend. So what I did here is I made I set the material to carbon steel. It doesn't really matter in this case, and then change the color to green. Onto files, properties. So I added here in custom material. I typed in material. I typed in part number. For material, I showed this in the previous video actually. I choose material, and then for part number, you enter your own part number, and then you hit OK in the bottom here. Essentially, now you've associated those 2 properties with this part. So I did that with the other 2 parts as well, obviously with different part numbers, and one with a different material. So again, you can always just change your material if you want. It doesn't matter in this case. I'm just demonstrating how you would do it. Let's just choose, I don't know, galvanized steel, for example, and then you would, because the color changed. In this case, because the color is still different from the other 2, let's save this. So this is gray, green, and then red, right? So the 3 different colors make it very, they contrast very, very well. So we're good on that part. So I think we can now go over how to make the assembly. So you guys should already have some practice with this from lecture and from doing your homework, possibly. So let's go into our assembly environment. So opening an assembly environment is pretty easy. You just hit the new option and then hit assembly instead of drawing or parts. So I did that already, and I saved it under the title assembly demo. You can probably name it assembly demo assembly to make it easier to assembly demo assembly, but your name, assembly name, and then assembly to make it more easily differentiable from the other files without looking at otherwise you have to look at the file type, and that could take a little bit more time. So that's just a possible tip to make things more easier. Okay, now, okay, so we can start by placing a component. In this case, before you even start, it's a good idea to check your view and find your isometric view and start there, because when you make your exploded view and put that onto the drawing, the isometric view will be your assembly from that angle, which means if you build it backwards, for example, if you start here, away from the isometric view, which is right here. Yeah, so if you start building right here, once they place your assembly in your drawing, it's going to be oriented weird, and it might not convey all the information that you want your audience or your audience to know. So make sure that you're in isometric view before you start building. So everything gets pulled apart, gets exploded in a way such that you can see all the holes and all the different edges that might come together. So in this case, I'll actually show you guys what happens if you do somehow start on the wrong perspective and how you can fix that to make sure your view looks correct. So let's start on the wrong orientation. So preferably you start on the correct orientation, but I'm just going to show for demonstration's sake what happens, how you can fix your assembly orientation if you start in the wrong orientation. So make sure your units are in NMGS just to be safe. Save again, insert component. So when you're inserting a component, you always want to insert like the main component, the base component, the largest component, either one of those. So you want to choose a component that you can build around. So in this case, this is a component I can build around. So I'm just going to place it down. Actually, let me go back real quick. Insert component. Notice here, you can change your orientation before you even place it, right? By using these buttons, you can essentially orient them before you even place them onto the assembly environment. And also the first part you place down in your assembly environment will be fixed. F for fixed. So it's automatically fixed because it's like the starting point, your origin essentially for your assembly. The first piece will be fixed, and everything else you'll have to basically mate them. By mating them, it's basically constraining them to this fixed piece, first fixed part. So you'd be constraining your other parts around this first fixed part. Now, so as you can see here, this orientation is what we want, but because we're not in isometric view, this is what we'll get in our drawing. And as you can see, like the hole here, right, is not really displayed, and that is basically concealing some information and making it more difficult for your audience to understand what's going on in your drawing, essentially. And they'll have to assume more things. You need to have other drawings to or make a note or something to let them know. So you definitely don't want that. But for demonstration's sake, let's go back. All right, let's place our other components. It's a component number 2. I conveniently named all of them, so I know which order I want to go. So again, let's just orient this to save some work later on to make things less confusing for ourselves. So Y again. All right, so this is how I wanted to fit with the hole, matching the hole. This is a very ugly color. I'm gonna save the document and then go back to our demo, to our part file, and change this appearance. It's just bothering me a lot, so I'm going to change that real quick. There's a variety of choices. You can choose high gloss, low gloss. These are basically textures, and then you can choose after you choose your texture, you can choose your color. So make sure you click this select geometry part, Assembly Demo 2 SolidWorks part file. So you want to select the part, not a face. You can actually set individual colors to individual faces. But why would you want to do that? So I don't think there's a point in doing that. You can just click the entire part and set one color to the entire part. So I choose that. Oh, whoops! I unselected. I deselected. So I'm gonna go back. Click it down. Color. Check. All right. Now I'm gonna set this. Wait, I did not choose the. No, it's fine. Okay. So as you can see, the color is right, but the texture is still wrong, which means I'll need to actually go into advanced and change that. See if there's plastic. Oh no. Okay, let me just go back into actually the side menu here for appearance. Go into plastic. I just like to single plastic because it's a flat texture like this, and it just makes it easier to look at. And then I can choose like what, yellow, maybe this color, purple, light purple, lavender. All right, Cool. Sorry guys, it's bothering me a little bit. So I'm just gonna change that color. So now everything looks nicer, matte. I like that. Save again, constantly save just in case your SolidWorks craps out, because it often does. Mate, whoops. Oh shoot, I closed the file by accident. Let me just open it back up. Yeah, this is why you should put the word assembly afterwards so you can tell without looking at the file type. Assembly, there we go. All right, so now mate, basically there's basically constraints and relations between parts. So there's many of these might seem very familiar, because essentially they're just relations for parts, right? So in this case, if you choose two surfaces, SolidWorks will actually suggest what will be what they think is appropriate. So for example, if you click on, let's say, this surface, so it already selected the top surface over there. Let me redo this actually. Clear selection, pull this apart. So if I choose, oops. Okay, if I choose, like, for example, this top here with this surface on the inside, it would make these two coincident on the same plane. So they're now on the same plane. For example, if I drag this around, ooh, can I do that? I think I can drag. Yeah, okay, whatever. So if I drag this around, they're not on the same plane, right? But we don't exactly want this, because this is the wrong way. This is oriented the wrong direction, right? So to change that, you can leave your mate. Actually, you can just undo. And when you're selecting your surfaces, right, before you hit check, you want to make sure it's oriented properly. To change the direction, you just need to go to mate alignment, and then you can flip that to the direction that you want it to mate. So make sure this is appropriately mated first before you hit the check button. All right, so this is what I want. So hit check, and it will keep you in the mate tool, because it knows that most likely you're doing multiple mates, because typically you need to do multiple mates to fully define, fully constrain the extra parts you've added to your assembly environment. So let's see, we'll need to do a few more coincidences. So let's say this one, and yeah, let's do actually this inner cylinder, inner circle here with this inner circle here. Okay, click. Or just this circle. Sometimes it's a little bit finicky. You might choose the edge, you might choose the surface, but in this case, this is what we want. So it has suggested that we stick with coincident, right? But in this case, what's better than coincident is concentric. This way, essentially, these two circles are concentric in this, like, they're coincident on like an infinite like circular tube. So it's very similar to the concentric relation in your sketches, but just for parts. So let's hit check. So now this is stuck, right, on this infinite like line. Their center point is shared on this infinite line here. The center point is shared. The circle center points are shared on an infinite line. Yep, yeah. So to finish this off, we would just need to hit, for example, let's see what else can do. Parallel, nope. Perpendicular. I think we can use perpendicular here. So if we hit this surface, if we hit this surface and make it perpendicular to this surface. Never mind. I'll just stick with the easy one. So you hit this inner surface here and hit this outer surface and make those two coincident. What is this? Okay, so it's still selected perpendicular, so you could change that to coincident, and there we go. And that's now fully encased. So I've designed my parts in such a way that they fit together nicely if you can fully define them. So if you want these parts, actually, just let me know. I can just drop you guys the files for these components. You guys can play around with this, with these parts, and do your own assembly. And then we finish this by just hitting check. All right, now you see if, for example, if we are missing, if we suppress, pull this blue bar up, okay. If we suppress this forcefully, as you can see that there's now a subtract sign, right? A minus sign. So similar concepts as your sketches, right? If there's a dash in parentheses in front of your part or sketch, that means it's not fully defined yet. And as you can see, because we hit this thing now can move freely in this one dimension, right? We don't want that. We want everything to be fixed. Fixed normally. Everything should be fixed under normal circumstances. But there are circumstances where you will want to like free up a degree of freedom in a certain direction. So you can do some sort of like simulation with them or do some sort of animation with them. So, but normally you just want to fix everything. So make sure everything's fully defined, everything's fully constrained. So unsuppress, now everything is fully defined. Let's add our last component, which is demo 3. Okay, boom. Everything, it doesn't have to be in the right orientation when you place it. It's up to you really, because as you constrain this piece, this part to the existing assembly, it'll automatically orient itself. So as an example, because you don't have to flip this, you don't have to lean this one over or to rotate this one onto its side, because if you just do concentric, hit this surface and hit this inner surface here, it'll automatically reorient it to fulfill the constraint, fulfill the relation, right? So in this case, that is sort of what we want, but it's facing the wrong way. So come down here, same thing. You can choose the mate alignment. I want to flip that. There we go. So now it's concentric and flipped. Also, if you might notice, there's a lock rotation button here, right? If you check without hitting the lock rotation button, what happens is you can rotate this. And oftentimes you don't want that, right? You want to fix that, right? So to fix this, you want to, first of all, make sure you can actually do a few things here. You can add an extra mate. You can add an extra mate here by selecting these two faces and clicking parallel. And that would fix this screw, fix this bolt, and prevent it from rotating again. However, alternatively, you can also delete, yes, edit this feature. Alternatively, you can also just use that feature to align the screw. Remember, if you rotate this and you hit lock rotation, it's going to be locked in whatever state of rotation it is at. So if you lock it right now, it's locked while this surface, it's locked while this surface is parallel to this surface. And so you want to make sure that this is in the position that you want before you lock the rotation. And similarly to sketches, I'm pretty sure you can also, here, let me just try this just to be safe. Hit this, hit the surface, hit parallel. Okay, I'm not sure if you can over define this. Let me try this one more time. Let's say I want to do this and this surface here, parallel, check. Okay, so it doesn't seem like you can over define, at least to my knowledge. Well, it's not hard, it's not easy to over define in the assembly environment, but it will make things more annoying for you as you may want to free up certain degrees of freedom in the future. And so to do that, you'll have to suppress multiple constraints, multiple mates. If you use multiple mates if you use like redundant mates, for example, if you use too many mates, you can have to find every single one of them and suppress them to get your part to move, to be free in a certain way. So in this case, we're just missing one more mate, which is this inner surface. No, we don't want that face. Delete this inner surface, inner surface, inner surface. to this bolt inner surface. There we go. And that is our full assembly. As you can see here, fixed. The first part is always fixed. There's no more dashes in front of the second two parts. The two other parts I've added, everything's mated. All your mates can be found here. You can always go back in and edit them. You can always go back and edit them accordingly. Again, there's like more than one way of doing, more than one way of assembling your parts. There's definitely, it's based on your preference partially. It's also different levels of efficiency of what mates you can use to like lock down your assembly. So it's, once again, there's multiple correct ways of fully defining your assembly. All right, so now let's take a look at the exploded view. To make an exploded view, all you need to do is, first of all, let me show you what I meant by incorrect orientation. So if you go into isometric mode, if you go into view cube, and choose isometric, you get this. And you don't want that, right? And that's a common problem with sketches. You start on the wrong view and you get a drawing view an isometric drawing view that's oriented the wrong way, and it looks really weird and like unnatural, I guess, and not ideal, definitely. So if you go into assembly demo, drawing, if you place down the model that we have currently, which is assembly demo, double click. If it places down, as you can see, this is an isometric view. It hides the bolts. It doesn't really give as much detail as we would like. We will ideally have that side face over here. So the easiest way to fix this is not in the drawing mode. It's actually going back to your assembly and changing it there, changing your view, changing orientation view there. So to do that, you right click on here and you hit float. There should be a float button somewhere. Right click. There you go, float. And that basically means it gets rid of the fixed constraint. So now your whole entire assembly is still constrained with one another, right? It's still fixed to the initial part that I placed, but it's just that the initial part is not locked down now to anything, which means the whole assembly is not locked down to anything. So you can move it freely. At this point, you go into this little drop-down menu, hit rotate component, and you can free drag or if you want to be more accurate, by delta X, Y, Z. Then if you look at the axes here, Y, Z, X, we want to rotate this about the Y because this is the isometric view we're currently in right now, right? So we want this to be oriented properly in this view, in our current view. So to do that, we have to rotate this about the Y axis here. The question is how much, right? In this case, I think 90 should be possibly good. Let's test it out. 90, apply. Okay, now let's see. Let's check this, and then hit our orientation view cube, isometric. Great, so now, there we go. Now this is more of what we want. You can see the bolt, you can see some of the green. Again, this is why we have an exploded view, because obviously you still can't see everything. Often you still can't see everything, even if your view is correct. So that's why we have an exploded view, which pulls apart all your parts and display all your parts and roughly where they fit in your assembly. So in this case, if you're satisfied with your isometric view, you right click again and you just fix. So fix and float, two opposite selections, two opposite effects. Because now that we're satisfactory, now that our assembly is satisfactory, we can now go into we can now hit the exploded view button here. So hit exploded view, and it'll bring you to the exploded view like side menu. And it's actually really, really simple. All you can do is click on the parts, click on usually the screw, or essentially think how you would pull apart, how you would, if you had to thing physically present with you, right? If you're holding your assembly, how would you pull the whole thing apart to show somebody how to put it together, you know? How would you undo your assembly and then put it together again? So essentially, in this case, you can't really remove the purple component, the purple part from the green part without pulling out the screw, right? So your first step in this case would be pulling out this screw. So let's pull it by a certain amount. Make sure it's outside of the hole, so there's no overlap. We want them to be separated, but not too far away. So we want there to be a space here. It doesn't have to be exact. We just want there to be some space, and then, but not too far away. Now this is very important. Don't hit the check button here or check button here, because that would basically end your whole explode process. If you end your explode process, the only thing you can do is to fix your explode process, you have to restart. So if you hit the check button by accident halfway through your explode assembly, tough luck. You're going to have to actually restart, unless they changed that from in this version of SolidWorks. I'm pretty sure you can have to restart your entire assembly, explode assembly once again from the very first part. So make sure to never hit the green button until you're definitely sure you're happy with your exploded assembly view. So instead of hitting check, you actually hit done here, which is really, really stupid in my opinion, but you hit done, and that brings you to the next part. So it saves your first exploded parts, and it basically lets you continue on pulling your assembly apart. So now we want to pull this purple part upwards to show that, oh, this thing actually can be slid on onto the green component, and then this red bolt can be put onto the can be put through both components. So obviously, in terms of order, right, they can't really tell which one goes in first, but like intuitively, they know that, oh, this has to go on first. Otherwise, if you put this on, you can't put that on anymore. So in many of these cases, intuitively, it'll make sense. And all you do is just pull them apart, just a decent amount, to show that they're separate and to show roughly how they fit together and where they fit together. So that's good, done. And because we only have 3 parts here, just pulling it apart twice should be enough. You'll have more components, which means more steps. But I'm good here because of just a limited number of parts I'm using. So just hit check. I'm satisfied. I'm certain that this is my final exploded view. So go back to your view cube, isometric. All right, now this is how it would look like in your drawing. I think this is pretty satisfactory. So I hit save, and then now move on to my drawing. Okay. So the first thing you would do here is the same thing as you would do for your parts. You hit model view to place your component, right? So you want to insert. You can either insert parts or assemblies. So it works the same for assemblies as for parts. So double click and you place on your assembly. All right, so now notice how this is not exploded, right? Not the exploded view. You can actually choose here, show an exploded or model break state. So in this case, exploded view 1, not good, because I already did one actually. That's why there's 1 and 2. Usually you only see 1 if you did exploded view once. But if you screw up and you had to do multiple exploded views, they actually save them. So I guess you don't lose them technically. You don't have to redo it completely. But if the only issue with hitting the check mark button, right, back in the assembly, the exploded view sidebar, if you hit the check button before you finish your exploded assembly, then you'll have to restart it, because you can't just use your half exploded assembly, right? You need a fully exploded assembly. So don't hit the check button unless you've finished everything. To get rid of this exploded view, I usually just click this, and it just pops you back into your non-exploded view. There's a way to reopen your exploded view. I think it's just this. It's somewhere on the side here. I've sort of forgot how to do that. Maybe it's in view here. bounding box. Maybe just search up exploded view. I don't know why it's not showing. But there is a way to actually toggle your exploded view on and off here. I just don't remember how to do it. Let me check. Exploded view, where you at? Ah, there you go. I think that was it. Collapse. Explode. Ah, shucks. Okay, so because okay, let me just do this again. Restart, select the components, boom, I want to explode this again. Just as an example, whoops, I pulled in one part. Control Z, I pick a new part. Oh yeah, you can select multiple components to pull apart. So in this case, you can't really pull both of these components out because as you can see here, this is it's geometrically constrained here, right? You physically cannot pull this blue, you cannot pull this lavender purple piece off of this green piece in this direction. So you're gonna have to pull the screw out first. I mean the nut out first. So, or bolt out first, I think. Okay, so basically I'm just repeating the steps again. Okay, I'm just saying pull up. So the fewer pieces you have, the easier it is, obviously. So this is pretty simple, but it can get pretty complicated. Like on your homework assignment, I'm pretty sure. So check. Now I'm pretty sure I can just hit this, right click, collapse, right click, explode. Hey, there we go. All right, so that's where it is. So you can toggle that. Now, if you go back to your drawing, okay, double click this. Now there's a third view. So as you can see, because I redid an exploded view, it saves it down. So I can use either 2 or 3. They're both properly exploded. I'll just pick this one because they're pulled further apart. Honestly, I could probably pull this even further apart to make sure they're all separated. That's, I think, more ideal than what I did here. So you want to make sure if you can fit it on this page, pull this apart such that they don't touch each other or they're barely touching. But I think this is fine mostly. Yeah, because as you get more parts in your assembly, it's gonna get very difficult for you to make sure nothing overlaps. But I think this should be fine as long as they can tell which part is which and how they roughly fit with each other. You are good. So we do that. For the exploded view, it's fine if you just leave it in colors with lines. That way it looks nicer. And a common issue is not filling up the page. Make sure your part or your assembly fills up the page. You don't want to have a humongous page and have like 4 little views. That's a poor use of space and makes it harder for not only grading, but for your audience to like interpret your drawing. So make sure they're displayed in a decent ratio, in decent scale. So 1 to 1 is too large. Okay, so in this case, 1 to 2 is fine. You don't have to fill up everything, but just try best to fill up as much of the space as you can. Make it easier for your audience. So hit Control Save, always hit Control Save, always Control Save. Because again, you don't know when SOLIDWORKS will crap out. And this is not a reliable, not the most reliable program. Put exploded view on drawing. Okay, now BOM, build materials, and adding new columns to the bill of materials. So this is pretty simple actually. SOLIDWORKS makes it really easy for you to add a table. Some of you guys might have already tried it out. Tables, and then bill of materials. There you go. Select the parts that we want to build the bill of materials from. So we select this part. When this assembly, on this assembly, on the bill of materials to be built off of this assembly here. So let's see. You can keep most of these settings. I usually don't touch any of this. I just hit check, and I place the bill of materials right above the title block. It should go somewhere near the title block, ideally right above. And you can make it look nice by just pulling, by adjusting and the different column widths. Again, it depends on like how much OCD you have pretty much. So let's see. And it bothers me that this doesn't fit here. So I would align this line with that line typically, unless this is way too big. Well, unless there's like way too many columns. So essentially you can double click on most of these to change the column header. In this case, I'll have a column named part number. So I don't want this to be confused with part number. Item number, part number, it's confusing, right? So I'm going to get rid of this number part, just have item. And that still makes sense, right? Item 1, item 2, item 3. Okay. And part number, in the part number area, double click. Okay, when you double click and you can edit, if you double click and can edit the text, that column header is not like linked. It's not linked to a certain property of it's not linked to any property type or anything basically. So you can just edit what it is called, and to make this make this table make more sense, essentially. Let's see. However, if you do want to make this table, make this column header be linked to something, there is a way you can do that. There you go. You hover over the letter, right? This blue area, make sure the downward arrow is present, double click it, maybe once or twice. If it doesn't come up, double click it once or twice. Give it a few seconds in between for it to possibly load because there's some lag. So column type, part number, in this case, we can change that. Part number, custom property, and there should be a file name. Okay, file name. Or is it a part name? Whatever. Okay. So as long as it is displaying the right thing, you should be fine here. Most likely your part name won't change. So you can just keep the part name. Usually what goes here is like bolt certain dimension by certain dimension, or like block 1, base 1. So most likely this won't be changing too often. But there will be times where you have to make revisions, and that may change the inputs here. But then you can just change it by double clicking each individual cell. So again, let's change that to part name. Having all uppercase here makes it look nicer. So I prefer all uppercase for the title headers. For C, because at the start of the video, I showed you guys that the 2 properties we made, we're going to add those 2 properties. When we see a column here, right, we have 2 more properties to add, but only 1 more column. So you can just click right click either column, and you can hit insert here, left or right. So in this case, it doesn't matter because we haven't named either column. There you go. Stretch this a little bit, pull this a little bit, make sure it aligns. Sorry guys, it bothers me. Okay, so in this case, you can manually enter like what material, right, and do it yourself. But the easier way is just because we've defined properties, and those likely won't change too often. Double click, see custom properties, property name, boom, there you go. It comes up right here. So because our part numbers are the part number is shorter, the part number, the space that the part number takes up is smaller, right? It takes up less space than the material. I'm gonna put it in the smaller cell, but it's up to you again. So you can put in material here, but instead of doing that, double click on the letter D on this top blue bar here. And instead of hitting part number, I'll hit material here. So this is why I wanted to put this in a longer cell, because the material names are typically longer. But it's up to you guys. And it doesn't have to be in any particular order. Usually item comes first, part name, quantity last. The rest is like up to you, honestly. At least I don't have any particular like preference for order. Let's see, can drag this around. Okay, so it comes off the table, it comes off the title block a little bit, but like what can you do? You can definitely, actually you can do some things, but whatever. All right, so there we go. Hope that makes sense. You can always add more properties to make things easier, like surfaces, surface finish, mass, if you like, whatever makes comprehension of your drawing, of assembly drawing easier for your audience. Yeah, make sure to hit, actually, I'm not sure you even need to check millimeters. Typically, you don't dimension your, actually, I'm not sure about that. Hold off on that thought, actually. I am not completely sure on that. So now, yeah, not completely sure on that. You have to check the professor on that point, or let me know and I have to look through my own notes. But for now, let's move on. Now that we finished the bill of materials, we can move on to ballooning. So typically you can just hit auto balloon and everything will be solved for you. It's very simple. Auto balloon, and then you can drag the balloons somewhere. Okay, gotta hit check first. Check. So as you can see, it's conveniently labeled. Every component for you. You can move the arrow a little bit. Make sure the arrow sticks onto the surface though, or onto the edge rather. Surface is confusing, right? You want to make sure this points to the edge. See, 3 points to the edge of this bolt here, and 3, demo 3 here, part name demo 3, right? Item 3, 3. You see how like this is very helpful for the audience. They can just look at your bill materials. Oh, what is 3? And then they can just look at 3, or they can look at your assembly and ask, like, what is part 2? And what is the material part 2? They can just look at item 2, go over, it's called demo 2, the file is called demo 2, part name is this, material is this, quantity is 1. Quantity will auto propagate as you have more of the same part. So if I had two bolts of the same file, it's going to be, there's going to display 2 here. So going back, demo 3 is the bolt, demo 2 is the outer shell, right? Demo 2 here, 2 outer shell, 1 inner block, 3 is the bolt. So yeah, and that's basically how you do an exploded view drawing. I think that is mostly done. Let me check my notes. All right, yeah, that's pretty much it. Let me pause the recording real quick. I'll be right back to see if I got everything in. All right, so for your homework, actually, you'll need more than just the exploded view, the exploded isometric view. So not only do you need to have this view, you also need the non-exploded views. So basically follow the example, I think, follow the directions in the homework description, homework assignment, and you should be fine. But it should go something like, if I want to make other views now, you can just, where is it? Okay, drawing, project this view here. All right. It is not ideal, actually. Let me place a new demo view. Oh, okay. Exploded view 2. Yeah, okay. So technically you'd want like this and this view and like this view. So you want to pull it out like this, and you want to make this your isometric exploded view. You might want, it might ask for a non-exploded isometric view as well. So I'm not too sure about the homework assignment, but just follow their directions, but you know how to place down more than one view. So I think you should be fine. Let's see. Obviously, you can actually change the scale a little bit to make sure it fits on this page. I think 1 to 3 maybe should be fine. make sure to, yeah, 1 to 3 should be fine. Let's see. Place this view down, place this view down. I'm pretty sure you can toggle individual views to be exploded or not. Can I? Yeah, there you go. So you can toggle individual views to be exploded or not exploded. 2 should be enough. This isometric and the side view. It depends what they ask for again. So if you need to do that, you can do that. Just many options. And now you know how to do it. Delete this. Now you have 2, right? Okay, let's delete these 2 as well. Yes. All right. So now, if you want to place a regular non-exploded version views, if you want non-exploded views, do the same thing. I'm pretty sure it defaults to not exploded, but yeah, there you go. It defaults to not being exploded. And then just set your views like that. Bottom view. It should be good. In this case, top view is less helpful than bottom view. So actually, you might want to have a top view too here. The side view, you don't really need 2 versions because it's the same thing on both sides. It's symmetrical down the middle. So you might want the top view here. But again, think about like what your manufacturer, if you were to submit this, what they will want to know about your parts and how they fit together. So thinking about that, you're going to make this drawing as easy as possible for them to understand, which also includes not being too redundant. So you don't want to like add way too many views onto this paper, because then you're making, in trying to make it simpler, you're making it more complex for the manufacturer to understand, because it just becomes so messy and so busy basically on your paper, on your drawing. So I think that's everything you need to know for your homework, and good luck. And I hope this helps a little bit. So yeah.